Hello, I'm Seema and welcome to part 4 of the chapter Haloalkanes and Haloarenes. In part 3 we were doing nomenclature and I explained how do we do the IUPAC and the common nomenclature of haloalkanes and haloarenes. Let us now solve the solved examples and the in-text question that is related to this topic. The first solved example that you have in your NCERT textbook is that you have to draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. You have to name each isomer according to the IUPAC system and then also classify them as primary, that is 1 degree, secondary, that is 2 degree, and 3 degree, that is tertiary bromide. Whenever you have such a question, the formula that is given to you, we first move from the simplest possible isomer and then we move on to branching. That is, we will first go to the straight chain isomer. So let us start. The first isomer of the formula, now according to IUPAC nomenclature, the word root is where we begin naming. And when you are making the isomers also, you must always start with the word root. That is, there are 5 carbons, so we must first make the carbon chain. So the 5 carbons would be 1, 2, 3, 4 and 5. And there is a bromide attached, so we attach the bromine to the last carbon. Okay, and now you have the hydrogens to fill up. So when you have the hydrogens to fill up, how do you fill these up? The hydrogens, the terminal carbons have 3 hydrogens. The carbons which are attached to 2 other carbons would have 2 hydrogens. So this would be 2, this would be 2, this would be 2, and this would be 2 also. Now, every carbon is forming a single bond and you have this formula. And look at it, do you have 5 carbons? Yes. 1 bromine? Yes. And you should have 11 hydrogens. 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have 11 hydrogens. So this is the first isomer that we will obtain. How would you name it according to IUPAC nomenclature? According to IUPAC nomenclature, it has 5 carbons, therefore the word root is pent, right? It is saturated, so it will be N. And since bromine is always written as a prefix, therefore we will end it with the E, so pentane. And this is bromo. Bromine is present at the first. We start counting from this side. So bromine is the first carbon atom, so we'll write it as bromopentane. That is the name of the first isomer. Now, how do you classify it as primary, secondary or tertiary? The alpha carbon, if it is attached to one other carbon atom, then the isomer is a primary compound. And if it is attached, if it is attached to the alpha carbon and that carbon is attached to 2 other carbon atoms, then it is secondary. And if it is attached to a carbon that is attached to 3 other carbon atoms, then it is tertiary. Now here the alpha carbon is this one, the one that is attached to bromine, and it is attached to only 1 other carbon atom. So what kind of, you have to classify is it as a primary bromide, secondary bromide or tertiary bromide. So this one is a primary bromide. Let us come to the next one now. So after doing this, after making we will try to stick to the straight chain isomers first. We'll try to make as many straight chain isomers as we can. So the second possibility is to have a position isomer. That is, the bromine could be attached to a carbon that is not the terminal carbon and falls somewhere in the middle. So let us do that. Let us come to the second carbon now. You start with CH3. I'm now not bothering about the hydrogens, assuming that you already know that whenever you have carbon on the terminal ends and you're filling up hydrogens, there would be 3 hydrogens. And whenever you have carbons in the middle, it needs 2 hydrogens to satisfy, because the carbon is forming 2 bonds with 2 other carbons and 2 hydrogens will satisfy its tetravalency. And if there is a substituent, then that carbon will have only 1 hydrogen and the substituent will be attached to it, because net every carbon should have 4 bonds. So let's do that. So the second one, let us assume that this one has the bromine now. So we'll make the rest of the structure the same, CH3, CH2, CH2, and now this CH2 should have the bromine. So 1 hydrogen shifts from here to here. So you have bromine here and this CH2 becomes CH3. So now you have this as the compound. Let us name it according to IUPAC nomenclature. Again, there are 5 carbon atoms, so it is a pentane, and the bromine is present on the second carbon. So this would become 2-bromopentane. Right? The third isomer, and what is it? Is it primary or secondary or tertiary? The alpha carbon is attached to 2 other carbon atoms. Therefore, this one is a secondary bromide or 2-degree bromide. This is a hyphen, not a dot. Right? Let us now come to the next possibility. Bromine could be attached to this carbon also. So let us shift the bromine here. We'll get CH3, CH2. Now this carbon gets the bromine, so this becomes Br here. This remains only CH because carbon can form only 4 bonds. This becomes CH2 now, and this remains CH3. Now, how would we name this compound? We would name it as 1, 2, 3. Again, it is pentane, and the place of the bromine is on the third carbon. If I count from this side also, I get 3 bromopentane. If I count from this side also, I get 3 bromopentane. So I write this as 3 bromopentane. And this is also a secondary bromide, because in this also the alpha carbon is attached to 2 other carbon atoms. Now, you cannot shift the bromine to the next carbon. Why? Because if I shift bromine to this carbon, the compound the bromine will be on this carbon, which appears to be 4th from here, but it is actually 2nd from this side. So we will count it from that side. In other words, you will get the identical compound. This would be the same compound as that. So it is nothing but the same isomer, only this time you're not looking at it from the front, you're looking at it from behind. So it appears that from this side it may be the second carbon, but from behind it will appear to be the 4th carbon. So there is no difference. So this is the maximum number of straight chain isomers that you can prepare. So after making the maximum number of straight chain isomers, the next step should be to try to make one simple small branch. So let us shift this. Let's take the bromine to the end again, and let us make one branch here. So in all, there should be 5 carbons. So I have CH3, 1 carbon is here, CH3, and 3, this becomes CH, and there are 3 carbons already, 3, 4, CH2, CH2Br. So now in this compound also I have 5 carbon atoms, and the 5 carbon atoms there's a branch here. So on the second carbon there is a branch. If you treat this as a straight chain, this becomes the first carbon, second carbon, third carbon, fourth carbon. But we would always treat this as the first carbon because this has bromine on it. Right? Since this has the substance, we start counting from this side. So we say this is the first carbon, second carbon, third carbon, and the third carbon has a branch which is the methyl group. So we'll call this 3-methyl bromobutane, because now the main chain has only 4 carbons, and this methyl group is treated as a branch. I can alternately, instead of making this structure like this, I could make it like this, CH3, CH3. This makes it simpler for you to understand, right? So now this is 1, 2, 3, 4, makes it butane. This is methyl, so this will be 3. On the third carbon you have but, methyl and bromo. Remember, both of them are written as prefixes. Therefore, alphabetically B comes first, so we'll write bromo, 1 bromo, 3-methyl butane. Right? So this would be your compound. 1 bromo and 3-methyl butane. Now tell me, is this primary or secondary? Or is it tertiary? The carbon to which bromine is attached is a primary carbon. Therefore, it is a primary bromide. Since they're asking you, you have to classify them as primary, secondary or tertiary bromides. The alpha carbon is primary in this case, therefore this would be a primary bromide, right? Now the next isomer, that is the fifth isomer, what should we do? Let us shift this bromine now to the other carbon atoms, maintaining the same branching in the chain. That is, we want derivatives of butane now, with one methyl group attached at the second carbon. So keeping this as it is, we are shifting bromine to the next carbon atom, and we have the option of shifting bromine to this carbon, and we have the option of shifting bromine to this carbon too. So let us do that. So you have CH3, CH3, and now this CH gets the Br, and this CH in the end becomes CH3. How would you name this one now? Now you have bromine. If you count from this side, you can look, both the substituents are present on the second and third carbon. So which would be the right side of counting, of allotting the locants? The side which gets the lower locant for bromine, that is the substituent, would be the one that would get importance. So you will count from this direction. This becomes the first carbon, second carbon, third carbon, fourth carbon. So this becomes 2-bromo, 3-methyl butane, right? Come to the next. Now we are going to shift the bromine here, right? And if we shift the bromine here, you get CH3, another hydrogen is getting substituted by bromine instead. CH3 remains here. Oh, and we have to allot the primary, secondary, and tertiary there too. This becomes CH2 and this becomes CH3. This one, please tell me, what is it? Is it primary or secondary? The alpha carbon here is secondary because it is attached to two other carbon atoms. Therefore, this is a secondary bromide. And now, how about naming this compound? It is again butane, and both the bromine and the methyl group are attached to the same carbon. So we will not count from this side, because if we count from this side, we get the locant 3 for both the substituents. But if we count from this side, the locant that we get is 2. So according to the lowest locant rule, you always try to count from that side where you get the minimum locants, the lowest locant. So we'll count from this side. This would be 2-bromo, 2-methyl butane. So this would be 2-bromo, 2-methyl butane. And what would you say about this carbon? Is it a primary bromide, secondary bromide, or tertiary bromide? This carbon is attached to 3 other carbons, the alpha carbon. Therefore, it is a tertiary bromide. This is 3 degree. Now let us make the 7th isomer. For the 7th isomer, what is the option that we have? We can take bromine to the end now, and we could have 2 branches of, or rather not 2 branches, we could shift the methyl group from the second carbon to the third carbon. So this time, instead of moving bromine, we are going to be moving the methyl group. And let us see what are the simplest possible isomers that we could get. So CH3, CH2, CH, and we have the CH3 here now, and CH2Br, right? So CH3, CH2, CH, CH2, CH3Br, right? Now this is the compound that we have got, and it is substituted again. And what are the locants for bromine? We'll start counting from this side. Bromine is 1 and methyl group is 2. So we'll say 1-bromo, 2-methyl butane, right? 1-bromo, 2-methyl butane. Look here, this was 3-bromo, this was 1-bromo, 3-methyl butane, and this is 1-bromo, 2-methyl butane. So you always have to confirm that you're not repeating one of the isomers. Sometimes when we get too excited, we tend to make the same compound, And when you go back, you must make sure that you have none of the other ones that are the same, that are identical in structure. It's only that you may be seeing the same molecule from the front or from the back. There is a possibility of making that mistake. So now we have not repeated any compound. This is our 7th isomer, and this is again primary, because the carbon, which is the alpha carbon, is attached to only one other carbon atom, therefore this is also primary. Now we come to the 8th and the last isomer. In this, we have 2 branches of methyl groups. So what do? You have CH3, C, CH3, CH3, and C, since you have 5 carbon atoms, CH2, Br. Do you see? Now, in this compound, the bromine is attached to a carbon atom, and the carbon atom is attached to another carbon atom, what would you call it? A neo compound. But how would you name it according to IUPAC nomenclature? Now this becomes propane, and these are 2 methyl groups, so you will call it 1-bromo 2,2-methyl propane. 1-bromo 2,2-methyl dimethyl. 2,2, there are 2 methyls, so you'll call it 2,2-dimethyl propane would be your compound. And what kind of bromide is it? It's a primary bromide. So this was your solved example 10.1. Give me a moment, let me write down the next question. Now this is example 10.2. It asks you to write the IUPAC names of the following compounds. And let me just step away. This is so interesting. All the compounds, if you look at them, look so similar that you are expected to be confused, and that is the trick in this, that the structural formulae have been given, and just the bond line notations mostly. So since it is the bond line notation, it is deliberately been made in a way to confuse you. So I would change it into the expanded structural formula so that it becomes easier for us to understand how are we going to name these compounds. So although you could always use this to name the compound, this formula also, but just to simplify it for you, I would change the way it is written. Let us look at the first one. It has CH3, so whenever you're choosing the longest chain, you need to see the carbons, the longest carbon chain. This is carbon, this is carbon, this is carbon, and this is carbon, and this is carbon. So you have 1, 2, 3, 4, 5 carbons. So this is pentane, right? But let me first write the expanded structural formula of the compound so that our naming becomes easier. I'll write this. Whenever he has given us hydrogens, I'll just condense that. So we'll have the structural formula here. We have CH3, and this carbon has hydrogen, so I write CH. It has a double bond. Then I have a carbon here and a hydrogen here, which is attached to a carbon with hydrogen, and it has a methyl group here, and it has bromine. So if you really look, this is the trick here. The methyl group I would attach here, and the bromine I'll attach here. Now this makes it very simple for me to understand that the methyl group in the structure appeared to be a branch, while actually it is the bromine atom which is the branch and which is the substituent, and this methyl group is only an extension of the chain. So we get the compound here. Now in all of these compounds, if you see, there is a double bond. And whenever you have a double bond is the primary suffix. And a suffix is always more important than a prefix. So the -ine and -ines, whenever they are present, they'll get more importance than the alkyl group which is attached, or the substituent like bromine which is attached to it. So whenever you're numbering such a compound, you're writing down the locants, or when you're counting the carbons, you will count from that direction where the -ine, that is the double bond, gets the minimum locant or the lowest locant. So in other words, if I count from this direction, 1, 2, 3, third carbon has a double bond. But if I count from this direction, it is the second carbon which has a double bond. Therefore, my counting will have to be from this direction. So how many carbons do I have? 1, 2, 3, 4, 5. So it is pent. It is pent. And the ene is present at the second carbon. So I'll put a hyphen here, pent to ene. And the bromo is present here. So I write it is a bromo pent to ene, and the O and the P should be joined. It is bromo pent to ene. And what is the locant for the bromine? The bromine is attached to the 1, 2, 3, 4th carbon. So I write 4-bromo pent to ene is the name of the first compound. 4-bromo pent to ene, yes. Let us now come to the second compound. In the second compound, this carbon is the terminal carbon. Do you see? Because both of these are hydrogens. So this carbon is actually the first carbon and the double bond is present on it. So the first carbon has a double bond, then you have this carbon, second carbon, which has a methyl group attached to it. Then you have a third carbon to which the bromine, and the fourth carbon is the methyl group. So let us expand this again. This carbon becomes, this part becomes CH2, has a double bond. This is C, this is CH3, and this is further attached to this carbon, which is CH, and this has a bromine attached to it, and the CH3 is but an extension of the chain. So now, what is the compound? What is the longest chain that we have? The longest chain is 1, 2, 3, 4. So it is butane, right? Do you see? In this case, the compound was pentane. Pentene, sorry. It had 5 carbons. The word root was pent. But for this compound, although it has the same number of carbon atoms as that, it's only an isomer. This is 1, 2, 3, 4. It is butene. The word root is but, and it is an ene, and ene will get more importance. Therefore, this is the first carbon at which ene is present. So I'll just write butene, understanding that the ene is on the first carbon. Or you could also write but1-ene, just to specify the position of the ene. Then the bromo and the methyl groups are present. So when we are counting from this direction, the methyl group gets the locant 2 and the bromo gets the locant 3. But alphabetically, bromo will be written first. So we write 3-bromo, 2-methyl, 3-bromo will be capital, 3-bromo, 2-methyl butane. You could also write 3-bromo, 2-methyl but1-ene. Let me confirm this. Yes, but1-ene. Better specify the locant as it is done in the book. Although whenever you do not write the locant, it is understood it is 1. But no harm writing it down. Makes it fancy. Okay, now is the third isomer. What have they done now? What are the twists? You have a methyl group here, second carbon, third carbon. This becomes a branch, fourth carbon, and this is a branch. So let us first, so actually the ring, the longest chain starts from here, 1, 2, 3, 4, 5. The longest chain has 5 carbons. So, and there is a methyl group attached to it. So let us expand the structure. You will get CH3, CH, double bond, C, CH3, CH, Br, and CH3. Now this is the expanded form, the structural formula. Now it makes it very easy for you to understand what it is. The ene is present on the second carbon. We will count from this direction, we can tell. We can tell that we have to count from this direction because the ene gets the locant 2. This is the longest chain. You either count from this side or you count from that side. But you count from this side because ene gets locant 2. So 1, 2, 3, 4, 5. It's a pentene. It is a pent to ene. So let us write that part first. Pent to ene. That part is sorted out. Now you have bromine and methyl. We'll always write bromine first and methyl later. So bromine is present on the 4th carbon and methyl is present on the 3rd carbon. So we'll write 4-bromo, 3-methyl and pent-2-ene. Right? So I would always suggest you write this in the rough first, make a rough draft of this and then write a fair word, because sometimes when you join it like this it looks a little shabby. It should be continuous, so you'd write it clearly as 4-bromo, 3-methyl pent-2-ene. Right? It should be a properly written word in a single flow. Let us come to the 4th compound. So we have a methyl group here, the double bond is here, so let us first find the chain. This is CH3, 1 carbon, 2 carbon, 3 carbon, 4 carbon, and the bromine is attached here. So we will not choose this as the, if you choose, look here, 1, 2, 3, 4, you can get 4 carbons even if you choose this chain. But then the bromine comes into the branch, and we would not like to keep the bromine in the branch. The bromine comes in the main chain. Therefore, our chain becomes 1 carbon, 2 carbon, 3 carbon, 4 carbon. And that becomes a branch. So let us expand this, make the structure again. You have CH3, CH, double bond, C has a CH3 attached to it. And CH2Br. That's your compound. So what is the longest chain here? The longest chain consists of 4 carbon atoms, right? And if you look from this side also, the ene gets a locant too, and from this side also the ene gets the locant too. So if we count from this direction, we'll get the locants for methyl and bromine group also we'll get 1 and 2. But if we count from this direction, although for ene we'll get 2, but the locants for methyl would be 3 and bromine would be 4, which would not meet the requirement of the lowest sum of locants rule. The sum of locants should be the lowest one. You count from both the directions, and from that direction where you get the lowest sum of, and when do you do this? When is there a competition? When the most important functional group is getting the same locant from both the directions. Only in that case there is a competition of the lowest sum of locants rule. So now if I count from this direction, I would get the same locant for ene, but for bromine and methyl I'll get the lower locant, so I would choose that direction. So how many carbons do I have? 4. So this is butene, and the ene is on the 2nd carbon, so I'll say it is but2ene. And bromine is present on the 1st carbon, so I'll write 1-bromo, 2-methyl, but2ene will be my compound. 1-bromo, 2-methyl, but2ene. Yes. Now let us come to the 5th compound. This is CH3. Let me straight away expand this. This would be CH3, CH, double bond, CH, single bond, CH2Br. This turns out to be pretty simple. So now it is butene, and for the ene, the locant that you get from both the sides is 2, but you will count from that side where bromine gets the lower locant now, because ene is as it is on 2, count from either direction. So we would choose to count from this direction so that bromine gets the lower locant 1. If we had counted from this direction, bromine would have got the locant 4. So we know that according to lowest sum of locants, 2 plus 4 and 1 plus 2. Our 1 plus 2 is lower. So we count from this direction. So it becomes 1-bromo, but2ene is your compound. 1-bromo, but2ene. Yeah. And now we come to the last compound. Let us write it down to, this is CH2, double bond, C, yes, CH3, CH2Br. So it has a branch there. So now you have 3 carbons in the main chain, according to longest chain rule. 3 carbons makes it a derivative of pentane. And since there is a double bond on the first carbon itself, it is pentene. Prop. There are 3 carbons, it is propene. So propene, and the second carbon has a methyl group attached to it, and the third carbon has bromine attached to it. I cannot count from this direction this time, because the ene, if I counted from this direction, would get the locant 2. It would get the locant 2. I want the ene to have the locant 1. So I will write this as 1, 2, 3. 3 bromo, 2 methyl, prop 1 ene, propene, right? 3 bromo, 2 methyl, prop 1 ene, or just propene. So this was question 10.2. After this you have an in-text question. Let us solve that also. Let me write it down. Now this is your in-text question 10.1. Now they've given you the names and you're supposed to write down the structure. This is even more interesting. It's like a game, you know. So you're going to do the opposite this time. You have to write the structures of the following compounds. 2-chloro, 3-methyl pentane. You know, when you're writing down the structure from a name, I would like you to follow the same steps as you would do when you're naming the hydrocarbon. When we name the hydrocarbon, what do? We first count the number of carbon atoms, right? So we will first write, according to the word root, we'll choose the word root, we'll find the word root, and then we'll make the carbon chain according to the word root. So 3-chloro, 3-methyl pentane. So pent and ane. This is the word root and the primary suffix. What does it tell us? There are 5 carbons in the chain, and ane tells us that it is a saturated hydrocarbon. There should be all single bonds. So let us first do that. Make the chain. The chain has 5 carbons. So 1, 2, 3, 4, 5. You've made the 5 carbon atoms. And now we will fill up the hydrogens in the end in order to satisfy the tetravalency of carbon. And now see what are the other substituents or the functional groups that are given to us. So since now it is our choice and we are writing the structure of the compound, we would choose to count from this direction, in the regular direction, because whatever, whether the person is if we want the structure to be from the first carbon to be from this side, we can always choose to write it this way, and a person looking from behind would also ultimately come to the same conclusion. Therefore, to make it easier, we'll always count for all these compounds. We are going to count from the front, from the beginning to the end, as we would write. So this is carbon 1, 2, 3, 4, 5. The third carbon has a methyl group attached to it. So let us attach a methyl group. The second carbon has chlorine attached to it. So put a chlorine here. Now you have to fill up every carbon should form 4 bonds. And since every carbon should form 4 bonds, let us see, this carbon forms only 1 bond. So how many hydrogens does it need to complete, to form 4 bonds? 3 hydrogens. So 3 hydrogens for this. This carbon already forms 2 bonds. It needs 2 more hydrogens to form 2 more bonds, because every carbon is going to form 4 bonds. This carbon is already forming 3 bonds, so it needs only 1 hydrogen. This carbon is also forming 3 bonds. It needs only 1 hydrogen. That way it completes its tetravalency. And this carbon is forming only 1 bond. Therefore, it needs 3 hydrogens to complete its tetravalency. So that way every carbon is forming 4 bonds. It is a saturated hydrocarbon. The chlorine is present at the second carbon. The methyl group is present on the third carbon. It is pentane. Structure done. Number 2. The compound is 1-chloro-4-ethyl cyclohexane. Cyclo, the primary prefix, is very important. Now it is hex, it is ane, the word root, the chain consists of 6 carbon atoms. It is saturated, but it is cyclic in nature. So you could resort to the bond line notation here and make a cyclohexane structure. Alright, this is cyclohexane, where every corner is a carbon of the hexagon is a carbon. So let us take the top carbon to be the first carbon. So it says 1 chloro. So let us put a chlorine here. 1 chloro, and count this way. 1, this is carbon 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So 1 chloro, 4 ethyl. 4 is here. So ethyl, what is ethyl group? CH2, CH3. That's ethyl. So Cl you have here, and 4 ethyl, and it is cyclohexane. And you could expand it to make it every carbon here would be CH2, this is CH2, this is CH2, this is C1, 2, 3, so this would be CH, this would be CH, where do I write it? I'll remove the 4 from here. CH, this would be CH2, this is CH2, and this would be CH again. Every carbon for the hexagon. But you know, you can, the easier one is not to write the carbons for each one. Put this here, cyclohexane, this is chlorine, and this is the ethyl group. Ethyl group is CH2, CH3. So this is 1 chloro, 4 ethyl, cyclohexane. Come to the next question. 4. Tertiary butyl. What is the tertiary butyl group? Butyl group is an alkyl group which has 4 carbon atoms. But when you say tertiary, the carbon that is attached to the main chain should be a tertiary carbon atom. What is a tertiary carbon atom? A carbon atom that is attached to 3 other carbon atoms. So our branch should look something like C, CH3, CH3, CH3. And this should be where the branch is attached to the main chain. This is a tertiary butyl group. So we need a 4 tertiary butyl. The tertiary butyl is present on the 4th carbon. 4 tertiary butyl. 3 iodo. Iodine is present on the 3rd carbon. Hept means there are 7 carbons. Ane. So let us first start with the word root. Heptane. So the longest chain is 7 carbons. Make them 1, 2, 3, 4, 5, 6, 7. These are the 7 carbons. It's heptane. The 3rd carbon, let us count from this side, has iodine attached to it. Right? So I have iodine. It is 3 iodo, 4 tertiary. This is the 4th carbon. And it should have a tertiary butyl group. Tertiary butyl group is C, CH3, CH3, CH3. Right? So 4 tertiary butyl, 3 iodo, heptane. I've got the basic structure. All I have to do now is fill up the hydrogens. This carbon has only 1 bond, is forming only 1 bond, so it needs 3 hydrogens to complete 4 bonds. 2 bonds already there, it needs 2 hydrogens. 3 bonds already, so it needs only 1 hydrogen. 3 bonds already, it needs only 1 hydrogen. This carbon is already forming 4 bonds. 2 bonds, so 2 hydrogens. 2 bonds, so 2 hydrogens. 1 bond, so 3 hydrogens. Right? So this is the structure of 4 tertiary butyl, 3 iodoheptane. Next compound. 1,4 dibromo-bute-2-ene. Bute, 4 carbons. 2-ene. It is not a saturated hydrocarbon. So let us first write butene. 1, 2, 3, 4. 4 carbons, and second carbon should have a double bond. So it is bute-2-ene. And it has 2 bromine atoms, 1 and 4. So you have 1 bromine here. And I should expand it a little because I don't leave enough space for the hydrogens. C, double bond, C, single bond, bute-2-ene. Right. Now the dibromo, 1,4. 1 bromine is here and 1 bromine is here. Right? So that is dibromo, 1,4 dibromo-bute-2-ene. Fill up the hydrogens now. This carbon is forming one bond with bromine, one bond with carbon, 2 already there, so 2 more required. This is forming 3 bonds, so 1 hydrogen required, 3 bonds, 1 hydrogen required, 2 bonds, so 2 hydrogens required. So CH2Br, CH double bond CH, CH2Br would be your structure. Last compound, 1-bromo 4 secondary butyl. Just as we did tertiary butyl, the tertiary butyl group was a group in which the carbon which was attached was a tertiary carbon of the branch. Now the branch has a secondary carbon and the group is butyl, which means what would a secondary butyl group be like? CH. Since it is secondary, it cannot be the last carbon. It has to be the second carbon which is attached to the main chain. So CH2, CH3. This would be C3, so this will be CH. This is a secondary butyl group. A secondary butyl group would be 3. Right? CH3, CH, CH2, CH3. This is the secondary butyl. It is the butyl group. Butane would have been CH3, CH2, CH2, CH3. But if you have to make it a butyl group, you have to remove one hydrogen. But since it is the secondary butyl, it means the carbon has to be the carbon which is attaching itself as a branch. That should be a secondary carbon. It should be attached to 2 other carbon atoms. So it cannot be the terminal carbons. It has to be one of the carbons of the chain. So this becomes the secondary butyl group. So let us write the word root now. 1-bromo 4 secondary butyl 2-methyl benzene. So our compound is aromatic. The ring is benzene, and benzene is like this with alternating double bonds. You make the benzene ring first. 2, we'll count this as the first carbon. So 2-methyl, let us write this as CH3. 1-bromo, so let us put the bromine here, and 1, 2, 3, 4. The fourth carbon has secondary butyl group. So C, CH3, CH, CH2, CH3. This is the secondary butyl group. So it has 1-bromo, 4 secondary butyl, 2-methyl benzene. That would be the structure of the compound. So with this, I'll wind up today's video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.